Hello my dear students, welcome back to Easy Notes. Today we'll be continuing the chapter chemical bonding, in which we'll be studying about covalent and coordinate bond. Okay. In last lecture we have studied about ionic bond, but here we'll be studying about covalent and coordinate bond. So let us see what is a covalent bond. A covalent bond is formed by the mutual sharing of one or more pairs of electrons between two non-metal atoms. Right? Yesterday we have in last lecture I think we have seen that covalent bond was being formed by mutual sharing. Mutual sharing means one on one. One electron from here, one electron from here, two electrons from here, two electrons from here, between two atoms. Right? In that way, it was forming a which bond? Covalent bond. No ions are formed during this bond formation. There are no ions formed. Like there is no complete transfer. Ions will be formed when there will be complete transfer, either gaining of electron or losing of electron. But here there is sharing of electrons, so no ions will be formed here. So why does a covalent bond form? The first thing, because the non-metals have high ionization energy and do not lose electrons easily. Right? To form an ionic bond, ionization energy should be very low. But if the ionization energy is not low, because of high ionization energy, the electrons won't get removed from the outermost shell easily. So that's why what happens, they form a bond called as covalent bond by just sharing the electrons. So they share electrons to complete their octet and gain stability. So everyone wants to gain stability. That's how they gain stability, by just sharing an electron like this. Okay. So let us see here. Single covalent bond. Types of covalent bonds. It is formed when one pair of electrons is shared between the atoms. It is represented by a single line. For example, H2 molecule. Okay, H2 molecule. See, hydrogen has only one electron. So another hydrogen will also have one electron. They'll do what? Let us share the electrons. So they'll share electrons in this way. So they'll become what? Like this, H and H. These two electrons will be shared. Okay. In this way, the hydrogen molecule is formed and the single covalent bond is also formed between them. Now, double covalent bond. Single means only one pair of electrons are being shared. Here, it is formed when two pair of electrons is shared between atoms. It is denoted by a double bond like this. For example, oxygen molecule. Example, O2. So oxygen has how many electrons? 6 valence electrons. 1, 2, 3, 4, 5 and 6. Another oxygen will also have 6. 1, 2, 3, 4, 5 and 6. Now this oxygen will say I have deficiency of 2 electrons. So let's share 2 electrons. This and this oxygen will also have deficiency of 2. So this will also get shared. Now this has 8 and this also have 8. So they gain stability. So they'll form a bond in this way. O double bond O. Right? Double bonds. Next is triple bond. Triple covalent bond, where 3 pair of electrons are being shared between atoms. And it is denoted by 3 lines like this. For example, how about nitrogen molecule? N3 molecule. Sorry, N2 molecule. Sorry, my bad. N2 molecule. Okay. So 2 nitrogens are present. Each nitrogen have 1, 2, 3, 4 and 5 electrons in the outermost shell. So these also have 1, 2, 3, 4 and 5. So how many each electron needs to gain stability? 3 more, right? To complete an octet. So 3 more electrons. So this also need 3 more electrons. So they'll form a molecule that is N triple bond N2 molecule. Okay? Yeah. Next, to be remembered, what should we remember? Some molecules have combination of single as well as double or triple bond. Let us see. For example, C2H4. It is nothing but ethene. C2H4 is nothing but ethene. If we talk about ethene, we have 2 carbons and 4 hydrogens. So 1, 2, 1 and 2. See, carbon has 4 electrons in the outermost shell. 1, 2, 3 and 4. 1, 2, 3 and 4. Hydrogen has 1 electron. 1, 2, 3 and 4. Now hydrogen need only 1 electron to complete its duplet. So it will form a bond with carbon like this. See, in this way to complete its duplet. And carbon need totally 8 electrons, right? See here. First it will form a double bond here. 1 and 2. Double bond. Then it's forming a single bond. 1, 2, 3 and 4 bonds here. So one, see here, how many electrons does this carbon have? See here, if we talk about this carbon, we'll talk about this carbon. Wait, I'll just change the color and I'll show you. Yellow, this blue. See here, this carbon has 1, 2, 3, 4, 5, 6, 7 and 8. Totally 8 electrons. How many? Here, 1, 2, 3, 4, 5, 6, 7, 8. It completes its octet. Now, how about this carbon? This also have 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8 electrons. So in this way, in a single molecule, there can be a single bond as well as double bond. How about triple? If you talk about C2H2, 2 carbons and 2 hydrogens. Hydrogen will have only single, but carbon has 1, 2, 3 and 4. 1, 2, 3 and 4. So there will be a triple bond between these 2 carbons and the single bond between this. In this way, carbon will complete its duplet, whereas hydrogen will complete its duplet, both the sides, whereas carbon will complete its octet. 3 here, 6, 7 and 8. As well, this carbon as well. 3 here, 6, 7 and 8. Okay. So some molecules can have combination of single and double, single and triple. If you make a big compound, it can have all the 3 in a single compound. Okay. Next, covalency. What is a covalency? It is the number of electrons an atom shares. How many electrons can an atom share? For example, thus the covalency of hydrogen is 1, because hydrogen can share only 1 electron. Oxygen is 2. It can share 2 electrons, right? Because in the outermost shell it has 6. So it can share 2. Totally 8 in that way. Nitrogen can share 3, whereas carbon can share 4. Okay. Metals usually don't form a covalent bond most of the times. They won't share. Metal will lose electron because they have low electronegativity. But this hydrogen, oxygen, nitrogen, carbon, they are non-metals. They share electrons. Okay. Metals are the one, they lose electrons and become ionic, right? Cations. Next, conditions for formation of covalent bond. Both the atoms should be non-metal. First thing, remember, both the atoms should be non-metal. Both must have high electronegativity. Both must have high electronegativity, electron affinity, and also ionization energy. All these 3 things should be high. Electronegativity, why? To pull the electron. Electron affinity, love towards electron. Ionization energy, maximum energy required for removing an electron from non-metal, right? If they are high, what happens? If electronegativity is high, it won't let the electron of outermost shell to go. It won't allow the electron to lose. Electron affinity, it will also won't allow the electron to lose. Ionization energy, if the energy requirement is high, so the electron cannot be removed easily, right? Everything wants to protect the electron. So instead of losing electron, they'll just share electron and form a bond. There should be small or zero electronegativity difference. Very less or zero electronegativity difference. Like if you see here, I told you about H2, right? Both are same atoms. So zero electronegativity difference. O2, both are same atoms. N2, both are same atoms. So electronegativity difference can be 0 or very small. If we talk about CCl4, this is also a non-polar molecule. We can say they also form covalent bond. Which type of molecule we'll study. Okay, it is also forming a covalent bond. Carbon and chlorine, they have some electronegativity difference, right? But it should be very small or 0. If the electronegativity difference is very high, it forms which bond? It forms a ionic bond, which we have learned in last class. Next, non-polar covalent compounds. There are two types of covalent compounds, polar as well as non-polar. The compounds where electrons are equally shared between atoms. Equally shared. What do you mean by equal sharing of electrons? See, non-polar happens when the electronegativity difference is 0. When electronegativity difference is 0. Okay, see, 0 or negligible. The electronegativity difference between the combining atoms should be either 0 or negligible. It means that it should be almost a similar molecule. Same. See here, H2, O2, N2, CH4, CCl4, almost similar. Nearby, electronegativity should be nearby, very small or 0. At that time, we can see the compounds called as non-polar covalent compounds. Equally shared. What do you mean by equally shared? See, two electrons are being shared, right? H2, 1 and 2. They'll form a bond. It won't be like more pulling will be from this hydrogen or more pulling will be from this hydrogen. No one will pull the electron more strongly. They'll equally share the electrons. Simple, in simple way. If there is more electronegativity difference, which comes in polar compounds, this is non-polar, right? Which comes in polar compounds. If there is more electronegativity difference between the two atoms, okay, which are sharing the electrons, in that what happens, like if we talk about H2O, okay, now here oxygen and hydrogen, they have electronegativity difference more. Okay, so the pulling of electron will be towards oxygen more compared to hydrogen. So it will create a charge upon this, partial charge, not complete charge. No ions, right? So not complete charge, but a partial negative and partial positive charges will be created. This tends to lose electron, but doesn't lose completely. Tends to lose. More pulling creates a partial charge, which is high electronegativity compound gets partial negative charge, and low electronegativity compound gets partial positive charge. If the electronegativity difference is 0, it means that electronegativity is same or almost equal. At that time, the compounds called non-polar compounds are found, in which equal sharing of electrons is done. Okay. Conditions for the formation of covalent compounds, non-polar covalent compounds, we can say. Both atoms should have 4 or more electrons in the outermost shell. That is non-metals. Exception: helium, beryllium, boron, aluminium, etc. These are the exceptions. Okay. Both atoms should have high electronegativity, high electron affinity, and high ionization energy. This we have learned, right? And the electronegativity difference should be either 0 or negligible. Okay, for non-polar compounds. Okay, let us see. Hydrogen molecule. We have seen this, right? H2 molecule, hydrogen and hydrogen. 2 electrons, 1 and 1. This is a non-polar molecule. H2 in this way. Equal sharing of electrons. Cl2. Cl and Cl. Cl has how many electrons? 1, 2, 3, 4, 5, 6, 7. 2, 4, 6, 7. Yeah. This also has 7. 1, 2, 3, 4, 5, 6 and 7. So this will form one bond and this will form another one. Right? Cl and Cl. Single covalent bond. Equal sharing of electron. No extra pulling of any from any atom. Oxygen we have done. Nitrogen also we have done. Okay. How about carbon tetrachloride? See, 1 carbon, 4 Cl. 1, 2, 3 and 4. Carbon has 1, 2, 3 and 4 electrons. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So here chlorine will form a bond like this, like this, like this. And how about carbon? One bond will be from here, another bond will be from here, it will form here, one here, and one here. Carbon will form 4 bonds with chlorine. So chlorine got 8 electrons, carbon also got 8 electrons. All the chlorine got 8 electrons, right? Just carbon, because carbon has the valency 4, we need how many chlorines? 4 to equally balance it, to balance the charge, right? Yeah. Okay. Next, polar covalent compounds. Simple, the compounds in which shared electrons are unequally distributed, right? I just explained you about water between hydrogen and oxygen. The more electronegative compound will pull the electron towards itself a bit more compared to less electronegative atom. So developing a partial charges delta positive and delta negative. A molecule that has both slightly positive and slightly negative charge is called dipole molecule. Polar compound can also be called dipole molecules. Characteristics: the electronegativity difference is moderate, not more. If it was more, it would be an ionic compound. Just because it is a moderate, it can be a covalent compound. More electronegative atom attracts electron more strongly compared to less electronegative. In water, what happens if we put this molecule in a water? Which molecule? Polar covalent compounds molecule in water. Partial charge becomes complete ions. They'll dissociate easily. Those electrons which were being pulled will be pulled completely from less electronegative. Okay, this process is called ionization. Right? Pulling of electron is called ionization, right? So that polar covalent compound can become ionic compound in water. We can't say like that. We can say like that. See, polar covalent compounds get ionized in water. They dissociate easily in water, right? Pulling of electron becomes easy for more electronegative atom. Next, hydrogen chloride. See, HCl, hydrogen and chlorine. H and Cl. Hydrogen has only one, chlorine has 1, 2, 3, 4, 5, 6, and 7. So hydrogen will form a duplet and chlorine will also form an octet. So it will be like this, HCl, but delta negative will be on Cl and delta positive will be on hydrogen. So in this way the bond will be formed. Okay, more electronegative atom will carry delta negative and less electronegative will carry delta positive. Ammonia, NH3. Okay, hydrogen will have 1, 1, and 1. Ammonia has how many? 1, 2, 3, 4, and 5. Sorry, nitrogen has 5. So 1 bond, 2, and 3 bonds. One lone pair will be kept extra. What is the lone pair? The lone pair is something which does not take part in bonding. It is called lone pair. Okay. Water, I've studied here. Oxygen, hydrogen, and hydrogen. Oxygen, hydrogen will have 1 and 1. Oxygen will have 6. So 1, 2, 3, 4, 5, and 6. So one bond will be formed here and another bond will be formed here. So 2 lone pair of electrons will be remaining here, which won't take part in any type of bonding. Difference between polar and non-polar molecules. Non-polar covalent compounds and polar. Non-polar have small or no electronegativity difference, right? Whereas polar has large electronegative difference. Large means moderate, we can say, compared to this large. Okay, each shared pair of electron is at equal distance from combining atoms. No one will pull towards each other, right? Yeah. Here each shared pair of electron is towards the element with high electronegativity. Which has the high electronegativity? It will pull the electron towards itself more. These compounds do not get ionized, but these compounds get ionized in polar solvents like water. Example: O2, Cl2, CCl4, and CH4. Here example will be HCl, HF, H2O, NH3, and so on, which has a moderate type of electronegativity difference will come under polar. We don't have difference come under non-polar. Effects of electricity on different compounds. So let us see what are the effects of electricity. Ionic compounds dissociate into ions and conduct electricity in molten or aqueous state. We know that, right? Ionic compound, which we have studied in last class, what does it say? Initially, ionic compounds are crystal in nature, right? We have studied in last class. Crystal in nature. So if they come into water, what happens? They dissociate into ions. Like NaCl is a crystal. If it comes into water, it dissociate into Na plus and Cl minus, and they conduct electricity in molten or aqueous state. Polar covalent compounds ionize into water and conducts electricity. Same thing happens for polar covalent compound as well. If they come under water, they'll also dissociate easily. But non-polar covalent compounds remain as molecule and does not conduct electricity. Remember, important point. Non-polar does not conduct electricity, but polar and ionic can conduct electricity. More electricity will be conducted by ionic only, okay, because it can readily lose electrons. Next, comparison between electrovalent and covalent. Electrovalent, which we have learned in last class, covalent, which we are learning today. The first thing, property and reason. Nature, constituent particles are ions. Any hard crystalline solids will be present. Why? Why they are hard? Because there is an electrostatic attraction between the oppositely charged ions. But here, constituent particles can be gases, liquids, or soft solids, not hard solids, because there is a weak force of attraction between the molecules. Okay. Now, how about boiling and melting point? It has high melting and boiling point because of more force of attraction, right? Here it has low melting and boiling point because weak force of attraction. Here they conduct electricity, but in solid state they do not conduct electricity. In molten state they can conduct electricity. They do not conduct electricity at all. Why? Because there are no free ions, right? Here there are free ions when in aqueous state or molten state. Next, thermal conductivity. They are good conductor of heat and electricity, but they are not good conductors of heat and electricity. Just a minute. Sorry. Listen. So what happens? Thermal conductivity. It is nothing. Covalent compounds are poor conductor of electricity or heat because there are no free electrons or ions. Here, dissociation. They can composed of ions dissociate in molten or aqueous state, but they do not ionize in the solution. Because why they can dissociate? Because the water reduces the electrostatic force and ions become separate. Here no ions present, so but polar compounds may form ions in solution, right? We have studied. Non-polar does not dissociate at all, but polar can dissociate. Solubility. They are soluble in insoluble organic solvents. Soluble in water and insoluble in organic solvents, but they are insoluble in water but soluble in organic solvents. Soluble in water, insoluble in organic solvents. Insoluble in water but soluble in organic solvents, vice versa. Water is polar and we can see electrostatic force. Here organic solvents are non-polar, they dissolve the covalent compounds. Rate of reaction is faster in aqueous solution. Why? Because ions in the solution collide quickly and react fast. Here rate of reaction is slow in aqueous solution. Why? Because old bonds break and new bonds are formed. That's why the reaction is very slowly, right? Next type of bond is coordinate bond. What is a coordinate bond? The coordinate bond is a bond formed when both shared electrons are provided by one atom only. We have learned in last class, right? What was coordinate bond? Only one atom is sharing the electron to the other, right? The other atoms and the other atom which is not even taking a part in that, right? One atom is like, oh, I have many electrons, take it. Either it is sharing one pair of electron or two pair of electron, like that. Okay. The atom which donates the electron is called donor. The atom which accepts the electron is called acceptor. The coordinate bond is represented by an arrow. Okay, and the coordinate bond shows both ionic and covalent character. Hence, it is also called as dative or co-ionic compound. Okay, it shows both the characters, half ionic, half covalent, we can say. So we can call it as co-ionic compound or dative compound. So lone pair of electrons, right? Lone pair in covalent compounds we were studying. Lone pair is an electron pair which is not involved in any bonding. Lone pair affects the shape and polarity of molecules. It affects the shape. Why? Because here, if two bonds are like this and there is a lone pair between them, these are also electrons, right? So this lone pairs will repel these electrons and the shape may become like this due to lone pairs. Internal repulsion takes place and the shape gets affected. Next condition for the formation of coordinate bond. What is the condition? One of the two atoms must have at least one lone pair. They must have at least one lone pair of electrons. Example, NH3, H2O. Here nitrogen has one lone pair, here oxygen has two extra lone pairs. Another atom should be short of at least a pair of electrons. Another atom should need two electrons extra. Two electrons extra, not one. If one electron extra means ionic bond. One extra, one more, they'll form a bond. That is ionic bond. Here, both I need two electrons from a single atom, not from two other atoms, right? From a single atom. So here, oxygen, any atom which is donating should have at least one lone pair of electrons, and which one is receiving, it should have at least deficiency of a pair of electrons. Okay. Example here is H plus. Most used example is H plus. So hydrogen ion. Hydronium ion. It is not hydrogen, it is hydronium ion. Okay. So let us see what happens in H3O plus. Initially, we have 1, 2, 3, 4, 5, and 6. Right in this way, 1, 2, 3, 4, 5, and 6. And we have two hydrogens with 1 and 2 electrons. So this will form a bond 1 and 2. Okay, we form a bond. But H3O plus, if another H plus comes here, bro, I don't have any electron. Please lend me 2 electrons. Oxygen will be like, bro, I have 4. I'll give you 2. Take it. So what happens here? If H plus comes here, if H plus comes, it will form a bond like this. Oxygen, hydrogen, hydrogen. This lone pair, it will donate to this H plus, forming a coordinate bond, which is shown by an arrow. Similarly happens in ammonium ion as well. NH3, NH4 plus, right? We know that NH3 is formed like this. Nitrogen has completed 1, 2, 3, 4, 5, and 6 electrons in the outermost shell. Remaining 2 electrons will be present as lone pairs here. If another H plus comes here, this lone pair is being donated to this H plus, and this becomes NH4 plus. This gets a positive charge. Why? Because extra H plus came inside, right? Came inside. That's why. This also get a positive charge. Extra charge is developed. Why? Because H plus came, right? Okay. Next, hydroxyl ion. What is hydroxyl ion? We can understand this by self-ionization of water. What happens here? There is a water, right? In this way, with 2 lone pairs and 2 bonds. This is water. If water loses one hydrogen, why it lose one hydrogen? To ionize with another hydrogen, another water. See, there is another water molecule. Okay. If this lose one hydrogen, obviously this will accept one hydrogen. Now it will form like this. See, 1, 2, and 3. Hydronium ion plus this OH minus. Okay. This is called self-ionization of water. Water will get self-ionized with another water molecule. They both will get together. Obviously, right? In a stream full of water, there will be many water molecules. They'll get ionized with each other, and they form hydronium ion and OH minus. That is nothing but hydroxyl ion. Okay. Next, we'll solve some questions. The first one: solid sodium chloride does not conduct electricity. Why? Why it does not conduct electricity? Solid sodium chloride. It is an ionic compound, right? Why it does not conduct electricity? Because it is a solid and does not have free electrons, free ions, right? The strength of bond is weak. No, it is the strongest bond. It contains free ions. No, it does not contain any free ions. Option C is the right answer. It contains free ions as well as molecules. No, there are no molecules in the ionic compound. Which of the following compounds neither dissociate nor ionize in water? These are non-polar covalent compounds. Okay. Hydrochloric acid. This is a polar covalent compound. Sodium hydroxide, Na plus OH minus. This is an ionic compound. Potassium nitrate, K plus NO3 minus. This is also an ionic compound. Carbon tetrachloride. This is a non-polar. So this will be the answer. It neither dissociate nor ionize in water. Polar covalent bond is present in HCl. Here non-polar, here ionic and non-polar. Non-polar, ionic, and here non-polar. Next, fill in the blanks. Non-polar covalent compounds are dash conductor of heat and electricity, bad conductors of heat and electricity. Why? Because they do not even dissociate the ions. In a covalent compound, the bond is formed due to dash of electrons, sharing of electrons. Sharing of electrons. A molecule which has single lone pair of electrons is NH3, right? Because nitrogen has one lone pair, but oxygen has two lone pairs. Next, a bond formed between two atoms by sharing a pair of electrons, with both electrons being provided by the same atom. This bond is known as coordinate bond, because both the electrons are being shared by same atom. Give reason why ionic compounds do not conduct electricity in solid state. Solution should be commented below, because we have done this question already in today's class itself. Okay. Name the following or identify the terms. The chemical bond formed by the shared pair of electron, each bonding atom contributing one electron to the pair. Which type of bond? Covalent bond. The bond in which the electrons are shared equally between combining atoms. Non-polar covalent bond. A substance that conducts electricity in the molten or aqueous state. Electrolyte. Okay, which conduct electricity in aqueous or molten state. Next, compare the properties of covalent, electrovalent compound and electrolyte compound for the following points. Solubility. First thing is solubility. Covalent are soluble in inorganic solvents but not soluble in water. How about electrovalent? They are soluble in water but insoluble in organic solvents. Vice versa. You have studied, right? Yeah. Structure. Covalents does not have a structure like lattice, but electrovalent has a structure like lattice. They have a structure like normal. They can be gases, soft solids, or like a liquids. They form a structure like a molecules, not a crystal lattice. This forms a crystal lattice structure. An element L consists of molecules. L consists of molecules. So what is L? What type of bonding is present in the particle makeup L? Covalent bond, right? Because molecules are present in the covalent bond only, right? When L is heated with iron metal, okay, iron metal plus L, it forms FeL. Okay, what chemical term would you use to describe the change undergone by L? Okay, now L is forming covalent bond, so obvious L is a non-metal and Fe is a metal. So electrons are being shared, right? Metal always get oxidized and non-metal always get reduced. So it is undergoing reduction. Okay. Next, draw the electron dot diagram for the compounds given below. Represent the electron by dot and cross in the diagram. Atomic number they have given. Calcium oxide. See, calcium oxide, CaO. Calcium. What is the formula for calcium? 20, right? So we can write 2, 8, 8, 2. How many electrons in the outermost shell? 2. Oxygen have 6 electrons in the outermost shell. 1, 2, 3, 4, 5. We'll mention this as cross. 1, 2, 3, 4, 5 and 6. 4, 5 and 6. Now they will form a bond like this, CaO. Simple. Electron dot structure is this one. Okay. Chlorine molecule, Cl2. Cl 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Simple. Water molecule, we can solve by yourself because we have already solved it. This I had given in the last class, right, as a homework, but I have solved here. Give the electron dot structure of the following: NH3 and H3O plus. Both we have solved this. Already done. Elements X, Y, and Z have atomic numbers 6, 9, and 12. Which forms an anion, cation, has 4 electrons. Okay, let us see. If we talk about X, it has 6 electrons, right? So 2, 4. Okay. If we talk about Y, it has 9. So 2, 8, 1. And if you talk about Z, it has 12. So 2, 8, 10, 2. Okay. 2, sorry. My bad. This 2, 7, right? 9 means 2, 7. It is 10 and 12. Oh, okay. Proper. So which forms an anion? Anion is formed by non-metals. Non-metals are found in last groups, right? P block mostly. So 17th group, this is a non-metal. This forms an anion. Forms anion. It means Y. Which forms a cation? It has less number of electrons in the outermost shell. Okay. It is nothing but Z. Which has 4 electrons in the valence shell? Obviously XY. It's being seen here, right? Next. Draw an electron. How many times by? Methane. That is nothing but CH4. See here. C 1, 2, 3, 4. H4 1, 2, 3, and 4. 1, 2, 3, 4. Like this. And 1, 2. If you properly draw it, it will become perfect. Okay. 1, 2, 3, and 4. Magnesium chloride. We should include this C inside the circles. Okay. Magnesium chloride MgCl2. We have done it in last class. Next. The following table shows electronic configuration of elements W, X, Y, and Z. Okay. What type of bond is formed between W and X? W and X. W and X. See, it can lose 1 electron, it can gain 1 electron. Obviously, ionic bond. Ionic. Okay. X and Y. X and Y. 7 and 5. It seems to be like nitrogen family and fluorine family. Both are non-metals, so they form covalent bond. What is the formula of the compound formed between X and Z? X and Z. It can lose one electron, it can gain one electron. So Zx, same charges, right? So directly Zx. Wnx, it can also lose one electron, it can gain one electron. So Wx. So easy one. Which of the following have two sets of lone pair? Ammonia, NH3, no, one set of lone pair. Methane, no lone pairs. Ammonium ion, not even one lone pair. Water will have two sets of lone pair because oxygen carries two sets of lone pair. Which of the following about oxides are correct? Okay, a basic oxide is an oxide of basic oxide is an oxide of metal, not non-metal. Acidic oxides contain ionic bonds. Nahi bhai, it contains covalent bonds. And here it should be metal. Amphoteric oxides contain metal. This is true. Basic oxides are always gases. No, it can be solid, liquid, or gas. When a metal atom becomes an ion, okay, metal becoming an ion while losing an electron. It loses an electron and is oxidized. Yeah, true. First option is right. It gains electron, no. It gains electron, no. It is getting reduced, no. It is losing electron and becoming oxidized. Identify the following. The tendency of an atom to pull a shared pair of electron towards itself is called electronegativity. Right? That is nothing but tendency to pull electrons. The type of covalent bond formed between non-polar nitrogen molecule. Non-polar nitrogen molecule. Which type of covalent bond? Triple covalent bond. Right? Understood? By this, the second chapter, that is nothing but chemical bonding, is completed. We'll continue the third chapter in the next lecture, that is acid, bases, and salts. Till then, keep studying and keep following Easy Notes and Arshad Bhaiya. Bye bye.